This lesson is going to go through function notation and evaluating functions. So we talked about functions yesterday and or in previous lessons, and we talked about domain and range. But I want to talk about how a function is like a toaster and a blender. If we look at these two, remember that they have different functions. The function of the toaster is to toast your bread, and the function of a blender is to blend things. So if I put an input, which is my domain, input into the toaster, because of its rule, its function, it's going to give me an output of toast. If I put the same input, the same domain value into the blender, because it has a different function, a different rule, this output is going to be different. So if I have a function, and I plug in a domain value of -2, an input value of -2. I end up with a value of -3. The rule of this was to double the input value and then add 1. If, however, I have a different function whose rule is to take half of the value and add 1, then when I plug in -2, I'm going to get an answer of 0. So because the rule of this function was to take half and add 1, and the rule of this function was to double it and add 1, my output values that I get are very different even though I have the exact same input, just like my toaster and my blender. Function notation, remember that basically I'm taking y and I'm replacing it with f of x, and f of x is just saying it's a function whose variable is x. When I evaluate functions, essentially all I'm doing is substituting values in. So if I substitute, if you're used to looking at it this way and I say, okay, if x equals 3, I'm going to take 3 and plug it in right here. It's the same exact idea. If I'm asking you to evaluate the function at 3, it's saying, okay, plug 3 in and see what you get. So when I evaluate the function at 3, I get 6 minus 7, which is -1. Sorry. To evaluate each, I'm going to, remember you can pause this at any time and try these on your own rather than just simply watch me go through them. So I'm going to plug in -3. So when I evaluate this function at -3, I get 9 plus 2, which is 11. Evaluating my function at 2z, all I'm doing is plugging in 2z instead of x. 2z squared, remember I'm squaring the 2 and I'm squaring the z. And in this case, those are not like terms, so that's as far as I can go. Lastly, on this page, I'm going to plug in 4. 16 minus 5 is 9. Remember, once I have this in function notation, I could write this answer as an ordered pair, because when I plugged in -3, my answer was 11. I could easily write it as an ordered pair. This is the exact same question as the previous one. Alright, so I've got 4 cubed minus 5. 4 times 4 is 16. 16 times 4 is 64. 64 minus 5 is 59. When it asks me to evaluate it over a specific domain, all that means is for me to plug in all of the domain values they give me. So in this case, I get -3. When I plug in 2, I get 8 minus 7. which is 1. Plug in 3, I get 12 minus 7, which is 5. And when I plug in 4, I get 16 minus 7, which is 9. So now my range for this, when I plugged in these domain values, is negative 3, 1, 5, and 9. I'm going to go ahead and pause it here and just go ahead and write out the answer, but if you'll do the same, and that way you can just check your so you can check your answers with mine. But my range that I got when I plugged in these values for my domain were 1, 4, 7, and 10. Alright, now this one is asking me, okay, here is my function, and now f of x is negative 11. What is the value of x that I plugged in to get negative 11? Well, I can take negative 11 and put it here, and then solve for x to determine what x value would I have had to plug in order to get an f of x or a y value of negative 11. And when I do that, I end up with an x value of negative 5. Here we have a word problem. Mr. Greer started an online petition calling for more vegetarian options in the school cafeteria. So far, the number of signatures has doubled every day, and he started with 32 signatures. Mr. Greer's petition can be modeled by this exponential function. Evaluate f of 3 and interpret the results in terms of petition. So when I plug in f of 3, remember that I evaluate this by raising it to a power first. So I've got 2 to the third power, which is 8. And 32 times 8 is, let's see, 240, 256. So this is telling me that after the third day, he would have had 256 signatures on his petition.